Welcome to our next unit. This is a big one. We're going to look at different types of chemical bonding. And the first part of this unit, we're going to focus on ionic crystals and metals. And so there's this picture that shows all kinds of different gems or crystals, and obviously there's metal in there as well. And we're just kind of looking to compare some of the properties of the crystalline gems versus the metals. And so in this first question, there's no wrong answers or right answers. Compare the properties of the gems and metals. And so maybe you said something about the gems being more colorful. They're in maybe a little more crystalline shape. The metals are shiny, and so are the gems for that matter. Maybe we could test for things like electrical conductivity. We know that metals should conduct electricity, but maybe the crystalline gems wouldn't. And then when you get to question 2, we're looking at science and engineering practice on constructing an explanation. And so obviously gems and metals have different properties. The metals are bendable, and we know that from the last unit. Metals are malleable and ductile. I can bend them and shape them, and they can be drawn into thin wires or pounded into thin sheets. And they obviously don't break or crack, but a gem or a crystal might be a little different. And so even if you don't have like crystals at home that you can smash and test, you might think about like salt and sugar as kind of crystalline, and they're brittle, like we can smush them and we can grind them into a powder, we can crack them. So on a particle level, what might be different about a metal versus a crystalline gem? What might be happening to the bonds between the atoms in these materials that could explain the difference? And so again, no necessarily right answer or wrong answer. Like, what do you think might be a little bit different about the structure of the particles? So obviously there must be something about like metal atoms that allows them to move, because they can be shaped in different ways. We can change their shape and structure. So the atoms must be in just like a different arrangement so that they can be moved and shaped in different ways. But you can't do that with a crystal, so there must be something about the particles in a crystal that are like in a more rigid structure, and I can't just move them and bend them and shape them. Maybe in a crystalline gem, the atoms or molecules are held more tightly together. And that's the reason why I can't shape them in different ways. Or if I try to like pound them, they're going to crack, where I can pound a metal and it just flattens. And so here's kind of our anchoring theme for the first part of this unit. We're going to look at comparing properties of crystals, which we're going to eventually know as ionic compounds, versus metals.